Welcome to the video. So we'll try to solve this question on code forces, right? What the question says is that we are given a list of n integers. So these represent the lengths of n different sticks, and we'll have to either increase the length of a stick by 1 unit or decrease the length of a stick by 1 unit, and this will constitute one operation or one move. So we can do a k or any number of moves, and we'll have to create an equilateral triangle, as in we'll have to create three different sticks of same length, right? So we'll have to do this. We'll have to find the minimum number of operations which we can do and create an equilateral triangle from the given n different sticks, right? So basically what we'll do is we can just sort the list elements, thereby moving the elements to the nearest, moving the elements to the corresponding positions where the nearest elements will be adjacent to them, so that calculating the minimum number of operations required to make that equal to the adjacent number will be minimum in that case, right? So taking an example, so example 1, I've taken this fourth test case as example 1. I've sorted this array and calculated the difference for all the elements except the first and the last element, right? So for the second element, it will be equal to the first element, so it is 0 on the left side, 1 on the right side. For the second element, it is 1 on both sides. Similarly for all these elements. For this last but one element, the difference on the left side will be 1 and on the right side will be 3, right? So I've just recorded these differences. Total for this will be 4, right? So minimum of these values will be 1, right? So we are expected to return 1 for the last distance, right? Similarly, in this example, right, after sorting we'll get this list, that is 3377, and the difference for this will be 4. Like if we assume that this is a middle element, we don't have to change this element, we only have to change this element. We'll have to decrease this by 4 steps, right? So the total changes that we have to make will be 4. That is what we have recorded here. Similarly for this element, we don't have to make changes on this side, right? We will only have to change this element. We'll have to add 4 units to this stick, right? That is what we have recorded here, right? I guess that is clear, right? I think we can just write the logic for this. For each element except extremes, and define diff as absolute difference. First we'll have to sort the list, and after that define difference as absolute difference of the element with its neighbors, right? At the end, also keep track of the minimum such difference, right? And just return that difference, right? This is what we have to, right? Cool. I guess that approach is clear now. We'll try and solve the problem, right? So I have already added some boilerplate code here. So what it does is reads the number of test cases. For each test case, we will read the length of the array, right? Also, we are initializing the results to be outputted. This is a variable in which we will track the minimum number of steps required, right? After that, we are also reading the list. We are converting that into the proper readable string integer format, right? As you can see, currently we have all the list elements in this variable, right? After that, the first step will be to sort this list, right? And sorted this. After that, we'll just iterate through the list, and then list minus 1. We will do, we'll define the current steps, that will be equal to abs of input list element index minus input list index minus 1. I'll just copy this. This is a left side difference, and we want to add the right side difference, will just be this, right? I've calculated this. After that, we'll check if current steps is less than min steps, or if it is a first element, we'll just have to update that. This index is equal to 1, and then min steps will be updated by current steps, right? At the end of it, we'll just print min steps. Let us try and run this code. 2, 4 and 1, 1. Let us just comment that out and see. So it's fine. 2, 4, 1, 1, right? This is what is expected here. Cool. Let us try and submit the solution. So as you can see, it is accepted, right? So I'm just showing the code again once for your reference, right? We're just reading the test cases list and all that. Our code actual logic starts from here. We are just sorting the list. After in the sorted list, we are iterating through each element and finding the minimum distance it is from each of its neighbors, and we are adding that into this variable, storing it into this variable, and we are keeping track of minimum of such steps that are required throughout this list, right? That will be our answer, right? So as you can see, the time complexity will be n log n for this, because we are sorting this, and this won't matter, right? This is row of n only. So ultimately n log n for each test case, right? Cool. So as you can see, all the test cases are accepted. Cool. I think that is fine. That is it for now, right? I think I hope that helps you guys, and we'll meet in the next video. Thank you for watching, right?